Hello, guys and gals. We are covering 8.2. This is the last section for Chapter 8 before we take our test. Okay, so 8.2 deals with graphs. Graphs of polar equations. So we are going to focus on 4 of them. So these are going to be the ones you're responsible for. Okay, so the circle, the lemniscate, the rose, and the limacon. Okay, so we're going to look at different ways at solving, or not solving, but looking at different ways for graphing each of these. For the circle, what we're going to be doing is we're going to make a table of values. Okay. Same thing for the limacon. We're also going to make a table here, looking for very specific points. Okay, and then for the lemniscate and the rose here, these two, we are going to graph these by solving for the maximums. So we're not going to make a table here. And same thing with the rose. We're going to analyze the equation, use what we know from looking at it, and solve for maximums. If you use other methods in your trig class, that's fine too. Okay, so we'll start off with the circle and the limacon where we make a table because that's kind of straightforward, that's intuitive. Okay, so the circle. So the circle has two equations. It could be written like this: R equals A cosine theta, or it could be written in terms of sine. Okay, so recognizing the structure will be important as far as knowing which shape is going to be the graph. Okay. All right, so let's take a look at an example here. All right, so let's go ahead and graph R equals to sine theta. Okay, so I'm going to go ahead and make a table. Okay, and I'm only going to pick the angles that are easy to graph. So like if I get a decimal answer, then I'm not going to use that. Okay, so so I'll choose these specific angles. Of course, I'll choose the quadrantal ones, 0, 90, 180, 270, but the ones in between, 45 degrees, I'm not going to choose that because sine of 45 degrees is square root 2 over 2. I'm not going to choose 60 degrees because sine of 60 degrees is square root 3 over 2. But 30 degrees, sine of 30 degrees is 1/2. That's easy. Okay, so I'm going to choose 0 degrees. That one is really easy to do in my head without a calculator. 30, because sine of 30 is 1/2. 90, of course. 150, because it has a reference angle of 30. Okay. 180. Again, all the quadrantal ones and all the ones that have reference angle uh, 30 degrees. 270 degrees. That's a quadrantal angle. 330. And then we're back to 0 degrees or 360. Okay, so these are easy to do in our heads. Okay, so let's find out the radius r. So r equals 2 times sine theta. Sine of 0 is 0, so 0 times 2 is 0. Sine of 30 is 1/2. 2 times 1/2 is 1. Sine of 90 is 1, so 2 times 1 is 2. 150 degrees, sine is still positive, so positive 1/2 times 2 is 1. 180 degrees, sine is 0. 210 degrees, now sine is negative. 210 degrees, that's quadrant 3. So negative 1/2 times 2 is negative 1. 270 degrees is negative 1 times 2 is negative 2. And 330 degrees, again, that's in quadrant 4, so sine is negative 1/2. So times 2 is negative 1. And 360, we're back to 0 again. Okay, so these values are very easy to come up with, and then it starts to repeat again. Okay. So let's take a look. So I just went full circle to see what I get, and then after that full circle, it starts to repeat. Okay. So here's radius 1. Here's a circle with radius 2. Here's a circle with radius 3. And here's one with radius 4, which we don't really need. Okay, so let's go ahead and plot those points at 0 degrees. So again, here's 0, 90, 180, 270, 360, back to 0. Okay, and then we're dealing with 30 degrees. Okay, so all of the angles that I picked have reference angle 30 degrees. So we're not going to be too far away from the x-axis. All right, so starting from 0 degrees, we have a point at 0. Okay, so no radius. Okay, so nothing. Okay, we have here 0 radius. 30 degrees, 1. So right around here. Okay. 90 degrees, 2. 150 degrees. So that's 30 degrees right off of 180. So 30 degrees. So 150 degrees, we get 1. And then 180 degrees, 0. So that starts to repeat. 210 degrees, that's quadrant quadrant 3 with 30 degrees reference angle, negative 1. So you have to walk backwards. So that puts us right back here again. And then 270 degrees, negative 2. Okay. So you have to walk backwards. So that puts us right back up here. And 330 degrees, walk backwards to negative 1. That repeats that point. And then 360 repeats the point 0. Okay, so we have this here. So we notice that these points right over here started to repeat. Okay, so when you make your table, you could actually just use these. Okay, to come up with your graph. It will kind of let you know where your circle is because we are graphing a circle, right? So this one is a circle. And so we see that our circle is going to be the one that lies in quadrants 1 and 2. So it looks like this. That's about the best circle I can do. Okay. So when you have cosine theta, then it'll still be a circle, but it won't land there in that exact same place. So doing these this table of values for the full circle from 0 to 360 kind of helps guide you to where your circle is going to be. Okay. So do the same thing for if you had R2 cosine theta, make a table, except that cosine of 30 degrees is square root 3 over 2. So I wouldn't use 30 degrees. I would actually use 60. Okay. Because cosine 60 is 1/2. Okay. So that's the circle. Let's take a look at the limacon. Okay, so this one also has two equations, one for cosine, one for sine. So we have R equals A, and you will either have plus or minus B cosine theta, and we also have one for sine theta. Okay, and we actually have two different shapes depending on your A and B values. Okay, so if A equals B, then you'll have a heart shape. Okay. But if A is less than B, then you don't quite have that nice little heart. It's kind of a loop. So you would see something like this instead. Okay. So again, for the circle and the limacon, we'll make a table. Okay, so let's take a look at this example. Let's go ahead and graph R equals 1 plus 2 cosine theta. So this one, is it going to be the heart or the loop? Okay, so here it's going to be the heart. I mean the loop. Okay. So let's go ahead and make our table. Okay, that's not working. There it is. Okay. Okay, so here, since we're dealing with cosine, I'll choose all the quadrantal angles, 0, 90, 180, 270, 360. Okay, and then I'm not going to use 30. I'm not going to use 45. I'll use 60. Okay, so 0, 60, 90, 120, 180, 240, 270, 300, and 360. And let's just kind of see what we get. Okay, so 0 degrees. So here we would get 1. Cosine of 0 is 1. Times 2 is 2. Plus 1 is 3. Cosine of 60 is 1/2. Half of 2 is 1. Plus 1 is 2. Cosine of 90 is 0. So we get 1. Cosine of 120. 120 is in quadrant 2. Okay, so cosine is negative there. X values are negative. Okay, so we get negative 1/2. So we get negative 1/2 times 2. That's negative 1 plus 1 is 0. Okay. Cosine of 180 is negative 1. So we get negative 2 plus 1. 240, that's in quadrant 3. So cosine is still negative there. So that's going to be negative 1/2. So negative 1/2 times 2 is negative 1 plus 1 is 0. 270 is -1. So we get -2. Oh, actually 270 cosine is 0. So 0 times 2 is 0. Plus 1 is 1. 300, that's in quadrant 4. So cosine is back to being positive. Okay, because cosine are the x values. So cosine of 300 is 1/2. 1/2 of 2 is 1. 1 plus 1 is 2. And then back to full circle. So this is going to give us 3. Okay, so let's take a look and see what we get when we start graphing these. Okay, so here is my circle with radius 1, my circle with radius 2, my circle with radius 3, and my circle with radius 4. Okay, so let's just kind of stop there. Okay, so here is 0 degrees, 90 degrees, 180, 270. And then we'll be looking at the 4 angles in each quadrant that have reference angle 60. All right, so 0 degrees, march forward to 3. 1, 2, 3. 60 degrees, which is getting up there closer to 90. So march forward 2. 1, 2. Okay. 90 degrees, march forward 1. 120 degrees, 120 degrees, 0. 180 degrees, so facing 180 degrees, we have -1, so we're going to face 180 degrees, but then march backwards to -1. Okay, 240 degrees, 0. We already have a point there. 270 degrees, facing 270 degrees, march forward 1. 300 degrees, march forward 2. 1, 2. Okay, so here we have this loopy heart thing, and it's going to be in mostly in quadrants 1 and 4. So here, let's kind of go like this. And it does something like that. Okay, so that's what you would get. So that's why here with the circle and the limacon, it's kind of easy to do if you just make these real simple table of values. Okay, so that's the limacon. Okay, so let's go ahead, and as long as you do this table, you'll come out with the correct points, and you'll see when it's the heart, you won't have these two together. You won't have that. Okay, you'll just have one of them. Okay. All right. Let's go ahead and do the lemniscate, and then we'll close up with the rows. Okay, so with those two, we made a table of values, but for the next two, lemniscate and rows, we're not going to make a table of values. We're going to look for the maximum. So hopefully your solving trig equations is has been mastered. Okay, so these are the equations for the lemniscate. R squared equals a squared sine 2 theta. So that 2 theta is always there. Lemniscate is the only one that has r squared. So that's how you'll recognize when it's going to be the lemniscate, that r squared. And then we also have it for the cosine. So the lemniscate is a figure 8 when you graph it. So think of it an ice skater skating a figure 8. Lemniscate, figure 8. All right, so let's go ahead and take a look at this example. So because it's a figure 8, so maybe it looks something like this. Then what happens is we really only want to know this maximum point here and this maximum point here. So that's why we don't make a table. We just look for where these maximum radiuses or radii are occurring. Okay. So let's go ahead and graph r squared equals 4 cosine 2 theta. So clearly that fits the structure of the equation of the lemniscate. Okay, so we have the r squared, we have the cosine 2 theta. It's always 2 theta. Okay, and so here we have 4. So our radius here, let's take a look at that. So our maximum radius is going to be square root 4, which is 2. Okay. And this happens when cosine is at its max, right? And so that would be when cosine 2 theta equals 1, right? So the largest it can be is 1. So this is the equation that we're going to solve. Okay. So cosine 2 theta equals 1 when this angle is 0 degrees. Okay, and since we're solving for 2 theta, let's do another circle. So of this, so 0 degrees and at 360 degrees. Okay, if that were 3 theta, then we would do one more circle of answers. Okay, all right, so now let's go ahead and divide everything by 2. So we get 0 here and 180. So that's where your two, you can think of these as petals, are going to be, okay, at 0 degrees and 180 degrees. And it's going to have a radius of 2. Okay, so when you graph this, okay, so here is my circle with radius 1. Here is my circle with radius 2. And here is my circle with radius 3. Okay, so at 0 degrees and at 180 degrees, okay, so that is where my maximum radius occurs, and the maximum radius is 2. So I'm going to have that, and I'm going to have that. Okay, and so I can go ahead and draw my figure 8 now. So my figure 8 would look like that. Okay, so that's the lemniscate. So it's all about finding where those two maximum points are. And you do that by solving for when that cosine or sine equals 1. And make sure you do two answers here because you're going to be dividing by 2. Okay. All right, let's do the rows. Waiting for this to scroll up. There it is. Okay. All right, so let's go ahead and do the rows. Also two equations, r equals a cosine. So now here, it's not going to be 2 theta. It could be 2 theta. It could be whatever number, n theta. Okay. So they look very similar, but there are some tiny differences here between the rows and the lemniscate. So remember, lemniscate has r squared. Okay, it looks very similar to this. Okay, so except it's r squared. Both of these could be 2 theta. So rows could be 2 theta. The lemniscate could be 2 theta. So the thing that's going to distinguish them is going to be that r, whether it's r squared or r. Okay. All right. Okay, so over here, so the n, the number there next to theta, determines the number of petals. Okay. So if n is odd, so if n is an odd number, then you have n petals. So if it's 3, then you have 3 petals. If it says 5 theta, then you have 5 petals. Okay. If it's even, then you have, so like if that says 2 theta, then you have double the petals. So if that said 2 theta, then you would have 4 petals. If that said 4 theta, then you would have 8 petals. Okay. And then of course, A here would be your radius, the length of the petal. So that's why we look for the maximum length. We just need to know how many petals do we have, and where they occur. Okay. All right, so let's go ahead and do an example here. Let's go ahead and graph r equals 3 sine 2 theta. Okay, so again, this looks like the lemniscate, but the thing that makes it not a lemniscate is the fact that r is not being squared. Okay, so r is not being squared, so this is not a lemniscate. Okay, all right, so this tells me that I have not 2 petals, I have 4 petals, because remember, when it's even, you have to double it. If it's odd, then you have that many. Okay, so we have 4 petals, and that 3 tells me how long each petal is going to be. So each petal is going to have a length of 3. Okay. All right. So the question is, okay, well then where are these petals occurring? Okay. And that's where we have to solve for our maximum. Okay. So we are going to solve for sine 2 theta equals 1. Okay. And so just like up above with the lemniscate, okay, so sine here equals 1 at 90 degrees. But since we're doing 2 theta, we'll do another circle. So add 360 to that, we get 450. Okay, so we're solving for 2 theta. If that said 3 theta, we would do 1 more. If that said 4 theta, then we would do 2 more. Okay. All right, so let's go ahead and solve for theta. So we get 45 degrees here, divide everything by 2, and we get 225 degrees. So that's where 2 petals are occurring. So we have a petal at 45 degrees with a length of 3, so a radius of 3. And then we also have a petal at 225 degrees with a length of 3. Okay, but that's only 2 petals. And it says here that we have 4 petals. So the way you find the other 2 is you find out where sine 2 theta equals -1. Okay, So that happens when this angle 2 theta is at 270 degrees. That's when sine is -1. Okay. But since we're solving for 2 theta, I'm going to add another circle to this, and that's going to give me 630 degrees. Okay. If it said 3 theta, then I'd add 360 to that one. If it said 4 theta, then you want however many answers there are for this here. If it's 2, you should have 2. If it's 3, then you should have 3. If it's 4, then you should have 4. Okay. Divide everything by 2, and you get 135 degrees and 315 degrees. Okay, so this is these are the other 2 places where you have a petal, and again, your radius equals, in this case, -3. Okay, so you'll have to march backwards. All right, so let's go ahead and do these. All right, so I'm going to draw my circle with the radius 1. I'm going to draw my circle with radius 2. A little sloppy here. Kind of hard to do on a tablet. 3. And I'll just do one more. It's hard to do, especially when it's not keeping up with real time. Okay, so, all right, so let's do these 2 first. Okay, so 45 degrees, and I have a radius of 3. Okay, so 45 degrees is like right around here. Okay, so facing 45 degrees, I march forward, +3. 1, 2, 3. Okay, and 225 degrees is over here in quadrant 3. Okay, so facing 225 degrees, march forward 3. 1, 2, 3. Okay, and now let me do the other 2 from the -1, from this one over here. So 135 degrees, that's over here. That looks weird. Okay, hold on. All right, let me write it over. 135 degrees. Okay, so facing 135 degrees, my radius is -3, so I face 135 degrees, but I walk backwards. So 1, 2, 3 over here. Okay. And then 315 degrees is over here with a -3 radius. So facing 315 degrees, march backwards 3. 1, 2, 3. And there you go. There are your 4 petals. So your 4 petals. Here's 1, 2, 3, and 4. Okay. So some of the things you just have to kind of remember here is your number of petals. Okay, so when it's even, like we had, you have to double the amount. But when it's odd, so if it said 3 theta, then you would have had 3 petals, not 6. Okay. All right, so that is it. Hopefully you understood everything. If not, just email me, send me a message. Okay, enjoy your day.